Hello, welcome. We are going through binomial theorem, problems and solutions. So we are going to solve various problems that are involved in binomial theorem and which provide various challenges. So we are going to start with question 1 and we shall go through at least 4 questions. Now, if you've been told that in a maximum of 5 marks, find the coefficient of x raised to 6 in the expansion of 3x squared minus 5, raised to 7. Now, the question here is, this is the condition, x raised to 6. Now, for you to manage this question very easily, is that you need now to capture where this x is, and you must also be good in indices. Now, this x is raised to 2. So if x is raised to 2 and we do not have x on this other side, then you ask yourself, how many times are we going to multiply the power 2 for us to get power 6? So you find that we are going just to multiply, that is in A, you're just going to multiply 3x squared just times 3. See, power 3, so that you get power 6. Now, when you have identified that, then you realize that now the next value here will be -5, because the total, the sum of this power and this power that will be here has to total to 7. Then if this is 3, then this will be power 4. That is how easy it is. So when you multiply x raised to 2 into bracket raised to 3, then 2 times 3 is equals to 6. So when you multiply here, then you get that this is 3 raised to 3 here, and then we have x raised to 6. Now this is what they are talking about in the question. So in this condition, then, what will be our coefficient in this particular term? You see, what is the coefficient of this particular term? So we all know that when you have reached here, you can use binomial, you can use combination, which is very easy. So we can use combination here, and we know that this is 4 and the total is 7. So we can say 7, 4 here in the combination. Then 3 raised to 3. We have -5 raised to 4. Then x now is raised to 6. Now this is what they need. This is the coefficient that they need in the expansion of where x is raised to 6. Now, for those who are new to this, when we talk about 7, 4, this means it is 7 factorial over 7 minus 4 factorial, then 4 factorial here. This means that you're going to 7 factorial means 7 times 6, times 5, times 4, times 3, times 2, times 1. Then we have 7 minus 4 factorial is 3 factorial here, which is 3 times 2 times 1. And then 4 factorial, then it is 4 times 3 times 2 times 1. Okay, that is what it means. So 7, 4 here means 7 factorial over 7 minus 4 factorial, 4 factorial. So you can simplify this. 3 and 2 goes with the 6. 4, 3, 2, 1. 4, 3, 2, 1. So that now, in this case, you're remaining with 35. So 7, 4 here gives you 35. So it is 35 times, now when you have 3 squared, that is 27. Then we have -5 raised to 4, then x raised to 6, which gives you now, if you use your calculator very well there, you will get 596 625 x raised to 6. But what is the value? They just want the coefficient. So the coefficient is 59625. Okay, that is how easy that you can solve a problem of this nature. That is part A. So you can see how you can manage that. Let's look at part B. Part B, they also want you to find the coefficient in x raised to 8. Now, let's also use the same experience, but now x is raised to 8. Now, if x is raised to 8, so B, now we have the coefficient where x is raised to 8. So it's just looking at the function. Now, in this case, we have x squared outside the bracket. So it is the same function, but now we have x squared that is now put outside the bracket. So 3x squared minus 5. So we have 3x squared minus 5 raised to 7. So it is the same expansion, but in this case now it is there is x squared outside. Now, this is also a matter of exponents. You ask yourself, up to what level can you now get x raised to 8? If you want to get x raised to 8, then we talked about the exponents here. When you're multiplying the exponents of the same base, then we add. So when we are adding, then you find that this part here, for you to get a total of 8, and we already have 2 here, then this one has to be 6. This part here has to be 6. So what are you going to multiply here to get 6? So we are finding that we are still going back to what we had before. Okay? In other words, we are saying that because already we have x raised to 6, what are we going to add to get 8? So we have to make sure that 3x raised to 2 also has to be raised to 6. You know, this 2 times 3 is 6, so 6 plus 2, then you get 8, because that is the power of indices. Some of the laws of indices that the student must know, that if you have a raised to m times a raised to n, this is the same as a plus m raised to n. Okay, so when you add the powers, then you have to get 8. So this one tells you that we are going back to what we had before. You know, what did we have here? We had 4. Okay, so which takes us back to what we had before here. You can see up to x, where x is raised to 6. So this is the coefficient. Then we are getting x raised to 8. So what is the coefficient? As we have done it before, we know that this already, when you multiply this, you shall get x squared. Then you get, as usual, you get 27. This one, then x raised to 6. Then we have negative 5 raised to 4. So you can see now the power and power here, which means that you are getting 27 times, that is negative 5. I'm just grouping them together, raised to 4. And then we have x raised to, you can see now x raised to 8, because we are adding these 2. So when you have this, therefore, then we are getting the same solution as we got above. But remember also we had the combination here, which was 7, which was 7, 4. So which gave us 35. So which means that we have 35, we have 27, which means it repeats itself like what we had before. So which gives you the same solution, which is 590, 625 x raised to 8, which finally the coefficient is 590, 625. So it is the same solution, but the question has been asked differently. Okay, the question has been asked differently. So somebody has to be very keen with the way questions are being asked. Okay, so that is 5 marks. That is how to get 5 marks so easily in a particular question. This is how questions in the exams can be asked, okay? Or even as you read to get knowledge. Now, find the coefficient. Now, in the second one, it is the same thing. Now, let's look at the experience now that we have from above. We have said that now we are talking about x raised to 10. So let's look at it. This also gives us the same experience. So you check where you have x is here. So already x is raised to 2. So you ask yourself, which power are you going to have outside so that you get the power of 10? These questions are a bit easier. So we get that it is 5. So it is 5. So which means this term here has to be raised to 5, and the total is 8. So which means in this case, then we get 5 has to be raised to 3, because this 2 squared has to be raised to 5, because we need the power of 10. Okay, so that makes it easy. Now you go back and now get what is the coefficient, of this particular point. So then you get that it is 8. We have a total of 8. Then out of 8 we are selecting 5. So then we have 5 raised to 3. Then we have 2x squared then raised to 5. So this is now what we have. So when you check this, then we are getting the power of 10, okay, in this particular case. So what are we getting? So if you get 8.5 from your calculator or from the expansion that I've shown you above, you'll get here is 56, and then we'll get 5 is raised to 3. Then we get, remember, 2 raised to 5 here. We have 2 raised to 5, and then x raised to 10. You see, we have now managed to get that. So this is the coefficient of to the expansion where x is raised to 10. You see, it is very easy. It is very easy for you to get this. But then it needs you to do quite a number of questions for you to get enough experience. Now, when you multiply this, you can use your calculator here, and when you multiply here, you get 22400x raised to 10. So which means they just want the coefficient. The coefficient then is 224,000, like that. So, and that question is solved. That question is solved. So when you come to B, let's see the experience in B. So they want now, what they want in B is the constant term. You see this one, these are the constant term in the expansion. Now, in this case, we have 3x and we have x. So we have x on both sides. So if you check properly, when we have a constant term, when we have constant terms, you find that in the area of the expansion, and we have division, then you find that in that particular term there will be no x. You know, we shall just have a constant value. Okay, we have to make sure that we have really divided the bottom, and that is the denominator, and the numerator, for us to remain with a constant term. That is what they mean by getting a constant term. So how do we get this one? Also, it takes us back to the laws of indices, which means that the division of 3x here, the expansion of 3x and of this 2 over x has to cancel one another. So you need to move up to the level where the 2 has to cancel one another. So if it cancels one another, which it means that then the index of the index of the 2 has to be equal. so that it cancels, or when you subtract the 2 has to be 0. This is what it means. One way of doing that, this particular question, so let me write it 3x. So we have 3x minus 2 over x, then raised to 8. So I want the student to look at it this way. Up to what term shall we have a constant? So it now means that this expansion of 3x, you know, 3x, the expansion of 3x raised to n, you multiply by the other one is a negative 2 over x raised to now the remaining, because when you add the 2 you have to get 8, raised to 8 minus n. You know, this is now what we have. When we subtract these 2, when you subtract this power, you must get a 0, so that this x and this x then will have to dissolve themselves. So which now means that we need to get the value of n so that we can now easily get the coefficient. So step number 1, get the value of n. How do we get the value of n? Now this one, we are getting 3 raised to n, x raised to n. The second part we are getting negative 2. We have negative 2, 8 minus n. We can multiply it times, we can separate them, 1 over x, you know, raised to 8 minus n. So this is now what we are talking about, these two. So you can bring this together, multiply by negative 2, 8, but what we are interested in is this one here, 1 over x, 8 minus n. So when we need to remain with constant here, then this power here has to be subtracted to 0, has to be equal, or when you subtract them you get 0. Okay, so what do we have? Then we have n minus 8 minus n then is equals to 0. Okay, because they are equal. If they are equal, then they become 0 as using the laws of indices. So which means that for us to get n, you open the bracket, then you get n minus 8 minus n is equals to 0, which means 2n minus 8 is equals to 0, which gives you 2n is equals to 8, then n is equals to 4. So after getting n is equals to 4, then you go back. What was your n? N here is 4, which means that our n here is 4, which means 8 minus 4 is 4. So both of them are 4. So which means that now we can say that 3x, so we can confidently say minus 2 over x raised to 8. This is now what we had before. For us to get the constant term, then both have to be 4. So we have 3x raised to 4, then negative 2 over x raised to 4. So this now will give you a 0. So now we get the coefficient here. Then we can now get the constant term. So what do we get? So we say now that we have 8, now we shall have 8 combination 4. You know, in this case, then we have now 3 raised to 4, x raised to 4. Then we have negative 2 raised to 4 over x raised to 4. Now you see when it is like this, you see now it cancels out. That is what we are now talking about, constant term. When it cancels out, what remains? It remains a constant number. Okay, we remain with a constant number. So we have 8, 4 here, 3, 4, that's 81, 2, that is 16, times 16 there. that is what we shall get. So if you have 8, 4, and that is 81 and 16. Therefore, from my calculation, you get here you get 90,720. Okay, you see. So there are ways, but alternatively, somebody can just expand until the 2 cancels out. You can still expand until the 2 cancels out. Now, because of issue of time, you know, so you can easily use this shortcut by finding the value of n first and then applying it in the question. Okay. Finally, in that part, we have the coefficient of x squared in the expansion this. So I think now you guys, you have the experience, so C can be easy for us. So now we have, you see, the questions are similar in various ways, you know, either one of them. So it is the same question. Now we have the expansion of x squared. So we have the expansion of x squared still in the same expansion. So in the same expansion, 3x minus 2 over x. So how do we find it? 3x minus 2 over x raised to 8. So up to what level do we have the power of 2 remaining? So if you look at it keenly, you know, the total is 8. And when you divide, the numerator and the denominator, then you can see that 3x has to be in 6, and then we have negative 2 over x has to be, let's see, no, 6 will be too high, so 6, 4, no, so it has to be, so that we remain with the 2, so it will be 5, then 3. That's all. That's all. Because the reason is that, look at what will happen, that we have 5, 3, we shall have 3 raised to 5, then x raised to 5, then you are multiplying it by negative 2 over x, you know, raised to 3. So x raised to 3, x raised to 5. What remains is x raised to 2. So this one now gives you the leeway to do the question so easily. So let me just expand it here so that you can see. So the numerator will be negative 2 cube, and then the denominator here will be x raised to 3, you see. So when you divide this and this, then you remain with 3 raised to 5. This one now will remain with, then we have negative 2 raised to 3, then x raised to 2. So this power 2 is what they are asking here. Now for here, then remember, don't forget to get the coefficient here. The coefficient here. So the coefficient is taken care of with the power of, or with the power of negative 2 raised to x, negative 2 over x, which is 3. So then you have, then you can have here 8, 3. We can have 8, 3 just down here. Then you can have 8, 3, 3 raised to 5, negative 2 raised to 3, which is negative 8. Okay, so when you put this one in a calculator, you get what? You get 56, then 3 raised to 5, then we have negative 8, then you get, then x squared. This one gives you 1088 from my calculator, 64 x raised to 2, which now means that the coefficient will be negative 108864, and that is your answer. Okay, let's see. How do we handle this particular question here? Look at the expansion here. This one looks a bit easier also for us from the experience. Now you just take the normal expansion, which is in part A, which is 2x minus 3y. Then we are just expanding to 3. Now what you do here is that, remember the simple expansion. We have x raised to 3, x raised to 2 be 1 plus x raised to 1, then ascending and descending powers of A power descends and B power ascends, okay? Then the coefficient 1, 3, 3, 1. This one becomes easier. Then our A is 2x, so we just fix them, 2x cubed. Minus, we have 2, then we have 2x squared. Now our B is negative 3y. Then plus A, which is 2x, then our B is negative 3y squared. Then finally we have negative 3y, that is minus, finally is minus negative 3y, then cube, just like that. Okay, that is the way you should look at it. Now we manage to let's put the coefficients. Then the coefficient is 1, so putting the coefficients which are here, don't forget them. So we have 2x, that is 8. We can have 8x cubed minus 3, 2 times 2, that is 4x squared. Then we have this one, you know, okay, when you are, you see this is negative. When you put negative here, then we should put the positives here throughout. Then when now we deal with this, then it can now bring the negative outside here. So negative 3, negative 3y, so you get times 3y here. And then we have, this is negative squared. So what did we have? We have the first one, we said we have negative, yes, that is fine. So then we have plus, the coefficient is 3, then we have 2 times 2, this 2 here, then times 3 squared, which is 9, then y squared. Then finally we have minus, because it will be 27, then y squared, like that. So as you finalize, then you can have that is, we can have 8 as 8x cubed, as we can see there, minus that is 4, 3, 36 x squared y, plus that is 3 times 3 times 9, that's 54 x y squared, then minus 27 y cubed. So that is your expansion. So you can use Pascal triangle, or you can use combination. Now the second one here, it is just the same thing, but then you do it differently. Then I'll just use a shortcut, because now we have known how to expand. We have 1 minus 3 root 3, then raised to 4. Now using the shortcut, and then I'll just put the coefficients. The coefficients, you can get them from Pascal triangle, or you can use the combination. Then we have, we shall have 1 raised to 4, obviously the coefficient is 4, 1 raised to 3, then we bring in 3, Then we have plus coefficient is 6, 1 raised to 2, root 3 squared. Then we have plus 1, 2, 3. Let me see, we have 1, 2, root 3, 6 squared. Then we have minus minus 6, 6. So you get minus coefficient is 4, then times 1 times root 3, now cube, but now this one is, remember it's negative, then it will make this one to be negative, you know, when this one is negative, this is negative 3. But now we have already changed the sign. So finally, we have minus root 3 minus root 3 raised to 4, which now becomes positive. When it becomes positive, then the sign remains negative because the sign keeps on alternate. No, this one now will be positive because this is an even power. An even power makes it to be positive. Now, after you've done that, now the work is to simplify. When you simplify, this is now what we are getting. We are getting 1 minus 4 root 3 plus 18. Now 18 now comes, you know, this part here, when you have root 3 times 2, you get root 9. Root 9, the square root is 3. Okay, the square root is 3. 3 times 6, you get 18. That's where these values are coming from. Then minus 12, 12 root 3, then plus 9. So 12 root 3 here, I know many students will have a challenge. Let me just bring it out. The challenge there will be we have 4. We have 4 there, then times 1 times, now root 3 is it is the same as root 3 squared times root 3 here. So this one is 4 times 1 times root 3 squared is 3, then you remain with root 3 here. So when you multiply this, you get 12. That's where the 12 is coming from. And then when you multiply this one by 4, it is the same as root 81, which gives you square root of 9, okay, which gives you here. Then finally, you will express your solution as 28 minus 16 root 3, okay. That is how you should do, that is question B, okay. So this is, you need to do more practice in terms of radicals. Finally, for today, I just want us to find ways of getting the constant term. Remember, we have already done ways of getting the constant term in an expansion. But in this case, now we have to find the value of k. What is the possible value of k that will give us the constant term when it is raised to 6? Now, we said the constant term, the student has to look at these two, okay? And we have done it in a very simple way. We said we have 3x raised to 2. Raised to what? When you multiply it by k over x raised to 6 minus this, gives you 0. The index gives you 0. So what is the value? So here we say now 2 times n here, you get 2n minus, then here we have only 1. So then we shall have 6n, 6 minus n, okay, is equals to 0. So what is the value of n that will give you 0? So we have 2n plus n minus 6 is equals to 0. So which means 3n is equals to 6. So n is equals to 2. So which means that our n here is equals to 2. So then when our n is equals to 2, how can we rearrange our function? So our function will be, then will be 3x squared. So n is 2. Over x raised to 1. So if x is 2, 6 minus 2 is 4 here. So then we have to get the coefficient here. Now the coefficient of this particular value is, we have the total of 6. Then we are selecting 4. This 4 here, we are selecting 4. Then here we have 3 squared, x squared. Then this other side we have 1 over x raised to 4. Then times k raised to 4. So you can separate them just like that. So you can see these ones. This one. So this one will be 4 here because 2 times 2 is 4. So you see it cancels out. So this one, then you have been given the value of this is equals to 84,375. So you've been told this one is 84,375. So we need this value. What is this value of k? Okay. So when you are solving it, then we can say that we shall have 64, then times 9 times k raised to 4 is equals to 84,375. So using my calculator here, when I multiply this, I get 135. K raised to 4 is equals to 84375. So if I divide by 135, K4, I get 625, which means K is equals to either, you can get either positive or minus 5, which either can work. So K can be either be positive or negative 5 because it is even. Okay, so that is all that you need. So in this question, the experience that we are getting, for the students to do this question easily, it is better for you to find the value of n. This one will simplify your calculations. Instead of expanding and wasting time, if you simplify it to that level, then things will work out. Thank you for today. That is what I had for you. Let's meet again in the next video. Goodbye.